Charlie here at Iowa State University, and it is my honor to introduce Megan O'Donnell with us today. Megan is the head of our Iowa State University Library Research Data Service Unit, which provides instruction and expertise on data management and data sharing for all of Iowa State's campus here. She also manages DataShare, which is our open data repository. And before becoming a librarian, she worked for the California Department of Food and Ag Library and assisted with the identification of invasive insects and invertebrates. And, I'm sure she'll be able to talk a little bit more about why that's really important because, you really don't want to have to throw your data away in the long run. Once again, on behalf of the NAPB Education Committee, we're excited that all of you are here today and hope that you're able to gain some awesome insight on data management and how we can crack that cryptic art of being able to use it wisely. So, Megan, I'm going to turn it over to you. Excited to have you with us here today.
Great. Thank you so much for that introduction, Clayton. So I'm a data services librarian, and what does that mean? If you've never met one before, that means I help people manage their research data and also help them understand what is involved with data sharing, because that's increasingly part of both publishing and research grant requirements. And if you're at a big university like Iowa State that does a lot of research, that's definitely something we have to comply with now and in the future. So out of curiosity, how many of you are currently in school? And you can do like an emoji or just do like a +1 in chat. And then, or you can, all right, so we definitely have some students. And then do we have any faculty? All right. And then I'm guessing we also have some industry folks in the room too. So, all right, postdocs, didn't forget, I never forget you. I just never know how to classify you. Awesome, I'm glad you guys are all here today. So because everyone's situation is a little different and this specialty in particular works with so many different types of data, this talk is really just going to cover some basics, but sometimes the basics are what we need. So I hope you all find it helpful. So the main things we'll focus on today are just like the basic concepts, the big picture ideas for data management, as well as pain points, how to tame file collections, how to do collaboration with data management, and then data management plans, both the federally funded ones and data management plans as a planning tool for yourself. So first, what kind of data do you work with? And you can either type this in chat or write yourself a note. And it could be the answer can be anything you want. So it could be messy, it could be spreadsheets, it could be images, it could be too much, whatever your adjective or noun of choice is. And feel free to share in chat if you want to, or that you can keep this to yourself. And yeah, various is good too. I see Sarah said that. Genome sequences, images, lots of images. Yep, those are tricky. Spreadsheets, field data. Yep. Oh yeah, geospatial. That adds another layer of complexity. All right, breeding histories, field and marker data. See, this is why I was like, I don't know. I can't get into too many specifics with you guys because you're doing it all. So as we go through this presentation, think about your data and how the concepts we're covering today can apply to your data, and especially the parts you want to improve. So what is data management? And that's why I titled the talk The Cryptic Art, because it sounds like a very technical thing, but it's not. So I took a picture of this poor person's desktop in front of me on the plane. And because this is data management, but then I also had the question of, or is it data management? Is it really data management? Because everything is there, but is it being managed, or is it just kind of thrown on the desktop? And so this is something a lot of us do. My desktop, I've had to work really hard to keep it organized and to keep files off of it without it getting to be a mess. And that was like a new habit I had to develop because I used to be this person. And if you can find everything you're looking for, So I feel so seen. Oh, Jane, I'm not calling you out. We've all been here. But this is the question is, are you actually managing the data or are you just reacting to it when it's like this? And I feel like it's more of a reaction than a management. So a more technical definition is the data management involves acquiring, controlling, development, planning, policies, sharing, and standardization of data. So it's a lot of different activities, and it's not just what you do with your files, but also some of what you're doing inside the files, how you're structuring things, what you're labeling things, consistency, and all of this intertwined things, as well as controlling who has access to them, what level of sensitivity they have, and who, if they can be shared externally, and also documenting them so other people, including future you, can use them later. So something to keep in mind is that research data management happens throughout the life cycle of a project. And so this is a life cycle that is very stereotypical of the academic research life cycle. If you're in industry, you may or may not be at the doing the share and publish stage, but you're probably doing every other part of the stage. And so research data management happens at every part of your process. You're just doing slightly different things. So the first thing you're going to do is you're going to start thinking about, okay, what do I need to collect? How am I going to collect it? Where is it going? Then you're going to, and that's where the file management comes into play. And then you're going to start working with that data. And then those choices you made earlier about how you collected it are going to impact how you can analyze it. And then that's going to then manage or impact how it's stored and what you're keeping and if you can keep it. And then how you can share it with others within your company, within your organization, and beyond. So there are so many different variations of data life cycles out there. I just chose one that was kind of simple. There are ones that have like steps and check boxes for each step. We actually kind of have a joke at some conferences about like it's a bingo square because there are so many different research data life cycles, and if we see more than one, you check off that square. But so this is not the life cycle, this is a life cycle, but it's a good overview. So the pain points of data management. So I have this silly little meme of these two men getting very angry at each other with an argument over a value. And for me, that means they're probably looking at a spreadsheet and they are trying to figure out or a formula or a script they ran, and they cannot figure out how they got the result they got. And data management helps prevent these things from either happening as often or from being as painful. And a lot of data management pain points is like general inefficiency, loss of files and data, wasted time and money, frustration and anxiety. I know I've had that happen a few times. I've lost folders on my computer accidentally, and that was a terrible feeling. And then errors and unreproducible results, which ties into that meme on the side, which is like you don't know how you got what you got. And it's probably because either a mistake was made or it might be because something's a little messy. So the next interactive question is, what is your biggest pain point? And or what do you most want to improve with data management? And this can be for you and your organization and your team. But I want to take a few seconds to think about this. Naming files, that's a good one. I think most of us could improve our naming of files. Consistency between team members, that is tricky. Another vote for consistency. More file names, collaboration, yes, these are all those pain points. A spreadsheet organization, I feel that one. Duplicate files, okay. Summary files, yep. Ooh, backups, that's also, yep, that's a pain point if you've ever lost something. Oh, that's okay. Consistency, master files, and combined data. Working off the same data set with multiple people. Yeah, you guys are doing, these are not easy things to solve, right? With technology, you'd think we have tools for it, but we don't always. Finding info years in the future. Okay, Hannah, we will cover some of that. All right. So this is all very real. Like I've had this happen to me as well, and I like to teach people. What I say is like I'm teaching you things I have probably done myself, so hopefully you will not go through the same pain I did. So something to keep in mind is that I kind of practice the philosophy of good enough data management because there's no one size fits all for everyone's research. Each project is going to be a little different. The problems with the files, the formats, the size, the speed of which the data is collected, how it needs to be organized, all the different team members, everything's going to be a little different. So it's hard to have a solution that works for everyone. Good or best practice, like aiming for a best practice, can waste time if you want something to be perfect. Instead, I would encourage everyone to go for good enough, which is it functional? And however, your good enough can change over time, which is good. Like you can keep improving and it will still be good enough. As you figure out your data management, weigh the costs and benefits against are you meeting the requirements, be these security, federal, local policies, group policies, all of that. And you also want whatever you're putting into place to be achievable and to be sustainable. And that means the sustainable part's really important because that usually means you have to commit to doing something. You or your team have to make sure you keep doing it. So those last two are usually where a lot of us stumble. I just saw Jane's note. That's great. We will actually talk a little bit about that, Jane, and we can go into more details later because that's a good one. Okay, so let's chat about taming file collections. So we all have tons of digital files. Many of them are being auto-generated through apps and we don't even manage them. The tool just has to manage them for us. But our research data, hopefully we're being a bit more careful with it and we're a little bit more hands-on. And so the goal with file management is that you want your things to be found and you want to be able to identify them very quickly and you want to be able to recover them without a lot of costs. That means not having to go to like a repair technician and having them restructure your hard drive after it had a major failure. Some very easy rules of thumb is to use simple categories, be specific with names, but not too long. Have a purpose with your organization. Don't just say, well, this sounds like a good category. Think about like, what is this folder for? Not just, oh, all of my text files are in there. Well, that's a lot of files. So that's not a great folder. And then stay consistent with whatever you choose. If you're consistent, that means you've established a system, and systems have some sort of logic to them and can be understood by you and other people. So let's talk about folder structures. One way to think about this is workflows, themes, and categories are your folders. And so we talked about how like a folder for all of your Word documents is a bad folder because there will just be so many. So instead you could do, well, these are all my class assignments folder. These are the annual reports. These are the field reports. You could just have different folders instead that are a bit more specific and still simple categories. One thing to point out though is the structure and format of your data may also determine your folder structures. So if you're collecting data day by day and it's a different file per day, you're probably going to have a folder that's going to be a whole month's worth of data or a whole year's worth of data. It's not going to be perhaps by site. Instead, it will be by date. So how you are collecting and organizing the data will also directly affect how you organize it. And then I would just say try to limit deep subfolders. So if you have more than 6 folders down, that's pretty deep. And if you're going that deep, you want to make sure you have at least 4 files per folder, because otherwise you could probably just have a good naming scheme for your folder or your files and have them in only 3 folders instead of like 9. So just think about like, what's the trade-off? Do I have to click more, or do I just have to like remember what I named it and which is faster? If you work with teams and do a lot of the same thing over and over again, creating a folder structure template is a really good way to go. This is also really good for onboarding new folks into your team. If you can just say, this is our team's template, this is what we use, this is where things go. It's, once again, it's a system, and systems can have logic, right? So then people understand what's going on. So let's take a couple look at different ways to organize things. So this is one that is organized by date. So by year, and then by month, and then by type of data. Though, because we don't actually know what's in the folders, it could also be like written reports could be in each folder too. But this is one way you could organize it. Here's another one. This is by project, and this one is by type of data and then by date. So this is what I meant about how you collect the data may affect how you organize your folders. And then lastly, this is by workflow. So each project, this is for an entire process. You're collecting data, you're doing analysis, you're writing scripts to process it, and you're writing your reports. So it's all together. I will say there is not, all of these are fine. As I was making these, I was like, I kind of like this one. And I was like, no, I kind of like the other one. And I was like, well, it would really depend on what I needed to file for which one I used. So I had to flip back and forth between this last one. This one is by theme or by project. And then this one is really by workflow. And the workflow one might work really well if all of your projects aren't are pretty separate. But if you're ever doing something that's larger, switching to the folder trees that are more date driven or type of data driven might work better. It just really depends. Okay, another reflection point. How organized is your data, and is it working? Brittany's using a 10-point scale system. 7.5 is not bad. Okay, hard to figure out which criteria to use for categorization. We have a good enough, I like it. We have a 6 out of 10. 7 folders deep, not good, but I understand it kind of. That's very relatable. Thank you for sharing. Yeah, these are all good. Oh, 4 out of 10, Katie. Well, I did say in the advertisement for this workshop, you would be able to identify something you could work on. So, I mean, that part's done. You can check that part off. So, oh, 10 folders deep. Okay, sometimes that's okay. So I won't, and sometimes it's too much. If it's taking you too long to find things, it's too much. Okay, I would rate my own, just so you guys don't feel bad, it like anywhere between a 6 to an 8, depending on which folder you're looking at. And my desktop is usually like a 4 if I'm really busy, because that's where I park temporary files. And then I go through sometimes once a month, sometimes every 6 months, and like delete everything I haven't worked on, because it's just a parking space. Okay. Okay, so file names, and I saw we had a question about file names too. So file names, and this applies to folder names too, should be as short as possible while remaining descriptive. And I don't mean like descriptive as in this is a Word document, because that is not telling you what's in it or why it matters. So the descriptive part has to apply to why this file matters and why someone would want to look at it or be able to find it. And so this ties into the comment about search engine optimization and keyword searching for files. You want to use keywords, not sentences, to describe it. And so that could be like when it was gathered, where it came from, the date you last edited it, what it contains, things like that. You also want to standardize your formatting for file names as much as possible. In general, stick to A to Z and 0 to 9 when possible for characters, spaces and dashes and underscores. If you're using scripts or commands, you don't want to use spaces because then you have to put the file name in quotes when doing a call to it to try and load the file or write to the file. If you're not doing that, I'm going to tell you they're probably okay. A lot of folks will say no spaces ever, but with the modern operating systems we have, most of them can use spaces without a problem. If you're using some older software or some like community software that someone made, it might be better to not use spaces because it might throw an error if someone forgot to do the quote command to load the file. But usually spaces are okay. I also tell you that Windows reads underscores as spaces when you search. So if you're on a Windows machine, you can use underscore and you can still do all your searches like it's a space. So if you don't want to use spaces, but you do like having words broken up, that's a good alternative. And then I'm going to introduce you to something called the International Date Standard if you haven't heard about it before. And this is how you would I will say probably the best way to do dates in any sort of electronic medium, which is 4-digit year, 2-digit month, 2-digit day. You can do it with or without dashes. And the reason to do it in this format is it will auto sort in chronological order this way on a computer. A computer does understand that January comes before February. F is before J in the alphabet. So instead it will put February above January. But if you do 01 for January and 02 for February, it will sort correctly. And so this was something I trained myself to do about 5 years ago, and I actually now have trouble understanding how we write dates in the US normally versus like the British way to write dates. And I'm just like, why can't we all just use the standard? It's so easy. And it will just really take out some headaches about like, okay, what date is this? Another thing I've seen is like people would do like year dash like Jan for January. Again, it won't sort correctly because it is the name of the month. So highly recommend switching to that format. And you can do this in spreadsheets too. Okay, formulaic names. This is something I think we're all pretty familiar with. So it's good because they shorten the file names, it keeps them organized, and they're descriptive. However, they can be very hard to understand if you do not know what the abbreviations are. So you need to make a key and you need to keep it with the files. This is as easy as opening a plain text file, writing down what everything means, and then just leaving it in the folder with your data files. It's not hard, we're never trained to do this for the most part. So I have an example from a data set we published on our data repository here at Iowa State. His file names for, the formulas region name underscore dash TA underscore SVCM SP underscore YYYYY 4Ts underscore 3Ds dot TIFF. And in his README file, he has, okay, the region name, here they are, they're mostly continents. And then this is an estimated data type, and then it's like 4-digit year. I forget what the T value was, and then the 3-digit day is day of the year. So it'd be like, the first day of the year, January 1st, would be 001. Last day of the year would be 365. And so just creating a very simple plain text file in your folder will help both future you and other people understand how you organized your files. Sometimes files are simple enough you don't need to do this, but for research files, I highly recommend doing this because I know I've started projects and I come back later and I do not remember what I did because I got busy and had to put something aside. So this is a really handy trick, and it shouldn't take more than 5 minutes. Okay, so let's also talk about file and data recovery. One, you should just always have a backup. And then do not store files on the desktop. So I had that photo of shame kind of in the beginning. The reason I created that is I found out that Windows backup ignores the desktop. And so if you do Windows recovery, like your computer really crashes and you have to do a recovery, it will not restore anything on your desktop. So that is the number one. That is one of the reasons not to store anything on your desktop. I haven't delved into the Mac side, and so I don't know if that's true on other operating systems, but just like I know for sure it's true on Windows. So it's okay for temporary. Like I said, I do that too. It's okay for like shortcut icons, all that's fine, but actual files of which are important, you should not store on the desktop for more than a day or two, maybe a week at most. Mark and make file versions for major changes. So if you don't already do this, your first draft, you just append version 1, version 2, version 3 every time you make a major change. So maybe your advisor goes, okay, you need to redo this entire section. You're like, okay, well, there's still some things I want to recover from the first draft. So you open it and you go file save as, and you change the file name to version 2. So you still have version 1 as a separate file to pull from. Very simple thing, but sometimes we forget to do it. And then exporting data from proprietary or uncommon formats when possible will really help you long term because a lot of proprietary software licenses expire. You may change computers and no longer have a software license that works. My favorite one is when the software company goes out of business and no longer provides updates. And so you just can never open your files unless you find an old copy of the software that you can make work. So this means saving into simple formats as possible. So often with microscopy data, for example, you'll have these multi-layered files that you can do a lot of analyses in, but maybe just export a flat TIFF of things as well. So even if you can't get into the version you can edit, you have a solid image and that part is still retained. Okay, Jane asked, is the issue just storing on desktop or storing locally on computer rather than server? That is a good question. A lot of that will kind of depend on how your organization has set things up. But the desktop is, I would say, one issue, and then the not storing on the server is if the server is just a backup, then it may not be a big deal. But if you're running a laptop, I would always say you need to put a copy somewhere else because laptops are portable. They can be lost, they can be damaged pretty easily. If you have a power desktop that's not going anywhere, it's a little bit more secure, but having a backups off-site is a good idea still. So let's talk a bit more in depth actually about file and data recovery. So I would highly recommend using some sort of cloud service if you have one available and having it set up to auto sync files. Here at Iowa State, we have Box and it works really good for most research files. It stumbles a little with really large files or with a multitude of small files, but that's just kind of like the nature of the software where it just has to take time to process them. It can still do it, it just isn't instant. Something else you might want to adopt is version control software. So Git and GitHub are very popular for this, but I will say they were built for software development and not science, so they're not the most intuitive program to use for many people. I know I find Git to be a little hard to use, and the terminology is very software development driven. And like, I'm like, well, that's not how I would think of that. So now I have to remember every time I click that button what it's actually doing. So if it's not for you, that's okay, but it does work for quite a few folks. Also, cloud storage providers might have file versioning built in. So in this screenshot, this is actually the version history of this PowerPoint file. And so you can see like when I was working on it, right, like yesterday. And then January 10th, so last week or earlier this week. And to do this, you just have to pull up the version history, and then for each version, you can either download a copy, make it your current version, delete or preview it. So it's really handy, and I don't have to remember to do save as version 1, save as version 2, because it's doing it for me. Whenever you're using cloud services, though, check your security requirements, because depending on where you work and who you work with and for, they may not want your data being on the cloud. So that is a restriction. Okay, another moment of reflection. Where is your data stored, and is it backed up? So by where is it stored? Is it on a computer? Is it on a computer in a server? Is it in the cloud? Is it in just a lot of places? Is it on an external hard drive? All right, we have cloud, server, OneDrive. All right. Yep, all right. Google Drive, yep, that's another cloud service. Local servers. Okay, so those of you running servers, something to think about is that server in the same building as where all my computers are? Because for like security and being able to recover quickly, if your building has a fire or is flooded, if everything's in the same building, that's kind of that can be a security issue. So I don't want to scare anyone, but that is something we challenge people to do in my profession, which is to think about not just, is it backed up, but where are those backups? And is that a good idea to keep everything in one place, or does it need to be more distributed? We have had a couple labs like have fire incidences. We had an instance where a deer broke into an office. That was weird. So things do happen. All right. Well, yes, a deer. It got trapped in a courtyard and broke a window. That was quite the story. All right, we have someone who says cloud into external drives because I lost all my data last year. I am so sorry you went through that. Nothing teaches us like experience. I've personally fried a hard drive. I plugged in the wrong power adapter and smoke came out of it, and that was the end of that guy. So, all right. So let's talk about collaboration, because I know we had quite a few questions about this. Okay, so moving data. And I have this silly little thing about like, we should take this data and move it somewhere else. And that makes it sound very, very easy, but it's actually not always as easy. We've been having to migrate off different cloud services here at Iowa State. And oh boy, did we find out all the quirks of Google Drive and Box and OneDrive in the last couple of years. One thing I will just say is avoid sharing files as email attachments. If you have access to a cloud provider instead, use that route. Email is not a good filing system for files or just for email. Honestly, my inbox kind of a mess. I try and keep it under control. There's just too many emails. So it's really easy to lose files in email, and email servers are just not built to store files, honestly. They're just not very good at it. So retrieving especially larger files through an email is not a good backup plan. And I have met people who have said their backup was in their emails, like they were emailing files to themselves. I did that when I was younger, so I'm guilty of that too. If you are going to move data, as I said earlier, cloud is going to be the easiest way to do it. And it's also going to be the safest because you can control who has access to it and for how long. If you have quote unquote big data, it's going to be a little tricky, and there are some special services like Globus that can help you move big data to colleagues. And depending on the service, there might be a download through FTP option. So it's an older protocol, but it does work. So I use that with Box for larger files because I can easily like suspend and pause a download and then resume it later if I need to, which is nice. You can't just do that when using the web interface. So I'm curious how many of you are sharing with other people you work with locally or if it's remotely. Because some of those are different challenges too. So remote, okay. Some locals, mostly remote. Yep. And so there are ways to access servers remotely too. And if they're set up correctly, those can be very secure as well. But that means you have to keep the server maintained. Yeah, more remote sharing than before. Yes, it's become very common. And I'm hoping in the next couple of years, we'll see some smarter tools for sharing files. Right now they work, but they could be better. Okay, so management systems are something else to consider. And so I just called it management system because there's a lot of different names for these tools, but these are systems that combine tasks such as file management, collaboration and documentation, change logs, data analysis, and publishing all in one roof. And so Open Science Framework is a really good example. Git and GitHub do some of this, but not all of it. And electronic lab notebooks like RSpace can do a lot, and they plug into other online systems. And so you can access like Git and GitHub from RSpace, and you can publish like to another repository from RSpace. It's kind of interesting. Now, if you want to adopt one of these systems, it will require an investment, time and or money. Some of them have subscriptions, some of them are mostly free or entirely free, but it will require some upfront investment to be worth it. And they can be worth it. I've seen some very impressive projects using these systems. So playing nice together, I think this is actually where most of us stumble. So New Year's resolutions, I will be exercising, I will be eating healthy, and I will be documenting. This is perfect because I think documentation is the main thing we don't do to ease friction while working together with data. And so I would say the first thing to do when you start working with others with data and collaborating is like actually make time to discuss this stuff and to make plans. And so actually carve out meetings. Like set up a meeting that's just like, how are we storing our files? How are they organized? And I know it's going to sound silly, but this will save time and might solve some problems if you just make time to talk about it. Something to think about is establishing templates and using standards together. So I linked to the Fair Sharing Standard Search. Let me see if I cannot easily grab the link. I thought I was going to. You'll get slides afterwards and you'll have the link. But you can see what other people have established for organizing their data, and that makes the data interoperable with other data. It means you don't have to spend as much time wrangling it to work with your own data. And then yes, this documentation part, number one thing most of us were not taught to do and we should be doing. So README text file talks, what are your file names? How are they organized? Do you have an inventory list? What are the methods you used? Stuff like that. Data dictionaries very similar, but for spreadsheets. I want to show you an example. So on the left is the start of a README file that's published on our data repository, and on the right is the data dictionary for some of the same data. And so it just, this spreadsheet goes with the main spreadsheet with the data and just says, this is the column TC stands for organic carbon. Its unit is a percentage, and it's a 0 to 15 value depth. That's it. But this information now means when I get that spreadsheet, it's not just a bunch of letter codes, it's information I can use. And this is, I would say this is definitely the #1 thing to do for you and your friends, because it will save you a lot of time if you start adopting this. So I highly encourage doing just little notes to self and data dictionaries. All right, I think this is our last collaboration question. So how do you collaborate and how do you share files? I already saw someone talking about Microsoft Teams, and yes, Microsoft Teams is terrible for file management. If you can hook it into something else like Box or even OneDrive, it'll work better. And yes, it's very frustrating because we use it a lot at my organization too. Oh yeah, Slack, okay. Google Drive, all right. So mostly cloud devised. Own Cloud is one I hadn't heard of before. I'll have to look that up. Okay, and because we are approaching time, I'm going to keep going. So I do want to briefly touch on data management plans. Data management plans are just a written document that outlines how your data will be managed and stored during and after the research. It is best to treat these as living documents, meaning as you go through the project and plans change, or something is no longer working, you update your plan so it actually reflects what you're doing. For federal grants, a shorter, mostly 2-page and static, meaning unchanging version that emphasizes data sharing is required for applying for federal grant money. So you can either use these, like I said, as your planning tool, and then there's also a version that needs to be submitted for federal grants. DMP tool is a great place to start if you've never made a data management plan. It is free for everyone. If you're from Iowa State, because I think I saw some folks from Iowa State, we have a subscription and your net ID will work. But you do not need it because anyone can sign up with an account. It has templates for a bunch of funders, and it also has this generic one shown in this image, which I really like because it asks just very simple questions, many of which we covered today as well. And if this is new for you or your team, starting with this, like filling out this template together, is a really good place to start. All right, I'm going to skip that because I want to leave room for questions after this section. So implementing change. Today was an overview of a really big topic, and I had to keep it very general because I wasn't sure. I knew all of you were going to have different data, so I wasn't sure who was going to be in the audience. Data management is mostly about us, not the data, though. If you kind of pick that up, it's about the things we're doing and the choices we make. And so I want to emphasize that we're also the ones who can change. And changing does take some time and dedication. And so make a plan and discuss it with the people who are involved, get feedback, make sure it'll work. I also encourage you to start small and improve one thing at a time instead of trying to redo your entire system from scratch. A reminder that it takes at least 1 month to establish or change a habit, so you do have to stick with it for an entire month. So if you start today, you could end right before Valentine's Day. And if you do manage to do this, you will start seeing a difference. And then after you have one new habit established, you can work on establishing a new one after that. So I challenge you to identify one thing you can change or improve starting today. data management wise, you can make other changes as well, but today's was on data management. And that's about it for today. When you get a copy of these slides, you'll have a link for like learning. There's a slide with some more resources if you want to dive more into the topic. So does anyone have anything they want to start working on changing that they want to share, or do we have any questions?
So as you guys start pondering and thinking about your questions that you want to ask Megan, first of all, I just want to give an awesome round of applause. If you want to do your reaction applauses, that would be awesome. Really appreciate that. I'm also going to take a quick second and drop a quick plug in the chat for the Borlaug Scholar Program while everyone's here and still attentive. So if you're a grad student and want to apply, make sure you do that by March 7th. Would really recommend it. But yeah, so what questions do we have for Megan? If you want to drop those in the chat, or you can also raise your hand and we can open up for actual conversation too.
Okay, Jane asks, what are some more resources for getting information and doing training? And so I have this learn more slide, and I'll make sure to send a copy to Clayton so he can distribute it to you. So the Australian Data Research Commons is a phenomenal resource. Australia did a nationwide response to data management sharing, so it's been very interesting to watch, and they're a little further along than the US and some other groups. The GISC Data Management Planning Guide is, I believe, out of the UK and is also phenomenal. There's a slightly older but still good introduction from the British Ecological Society that is a PDF that breaks things down very simply. And then a peer of mine wrote a book called Data Management for Researchers, Organize, Maintain, and Share Your Data for Research Success, which great title, also a really great book. I've had some grad students actually read it and come back and tell me they loved it and they told me they changed their lives. I don't know if that's actually true, but they enjoyed it. So it's a good read. And yes, I'll make sure you guys get a copy of these resources. Also, your local academic library and librarians can be a big help. I do consultations here. I've helped everyone from folks in the English department to the folks in like the genomics laboratory, because everyone has these challenges, right? Because data management is like partially like culture, partially actually technology, and then partially just trying to communicate with each other. And so facilitating that kind of thing, I mean, that's something you can do yourself as well. So I'm glad everyone enjoyed this, and thank you so much for the invite. Oh, we still have a few minutes, so if you have questions, keep them coming. Oh, Jane asked, I did miss this question. Feelings on having a data management specialist on staff instead of relying on everyone learning these skills. If you can afford it, that would be amazing. Folks who invest in data management project managers or just data managers for large projects, it pays off, because what that person does is they do what I do, but they take the next step and then go, this is what we're doing. And they make sure everyone is following it, and they give them templates, and then they can also do things to help clean things up as well. And so they're like a consistency checker. They're there to establish consistency and to hold you to it. So yes, if your group can afford to have one or has someone with those skills, that is a very important position to have on staff. And I do recommend it. All right, well, we can also end a few minutes early. Oh, Jane, you have lots of questions. This is great. Are there academic degrees that focus on data management? A little. So library and information science, and that's what my master's degree is in, does focus a lot on information theory and management. And data management is like an application of that. There are some certificate programs in the business world. there's a lot of data management stuff, and it's going to be slightly different flavor than what I presented today, because a lot of it will be about like getting your data managed for meaningful analytics and doing actions off that data, where mine is just like, I just want you guys to be able to find your things and not lose it and work together. So, but those resources can be very good. And you can find some videos, you can find videos on YouTube and places like LinkedIn Learning, I believe, too.
Awesome. Thanks for taking your time to be with us today. We really appreciate it.